Welcome to episode 2 of my How to Create a Programming Language tutorial. If you haven't seen episode 1, check out the card in the top right. In this episode, we're going to create our Lexer. The code you see right now is what we'll have by the end of the episode. We want to take input from the user and print a list of tokens. We'll also create a basic system for handling errors, as you can see in the terminal below. So, let's get started. I've started by creating a new Python project where we simply just print hello world. Now from here, we can begin to implement our loop. So what we want to do is to take input from the user until they enter a keyword such as exit. So we can take the line and we'll prompt them with just a simple prompt. Now, at the beginning of our language, we should print out something just to tell them that they're using our language. For example, if you look at the Python console, it tells you that you're using Python and then there's a prompt. We're essentially creating the same thing. So I'm just going to print out arithmetic 1.0. Right now, we are simply looping forever and getting a line of input. Now, if our line is equal to exit or whatever keyword you want to choose, we can break out of the loop. Otherwise, how about for now we just print the line back? So if we run this and I type something like 5 plus 5, it just prints it right back. And I can print gibberish and it will just print it back until we choose to exit. Let's start by creating a new module and let's call it Lexing. Now let's create a new file called token.py. And in here, we'll construct a simple token class to represent our tokens. Let's give it a constructor. It's going to take two arguments, a type, which we're going to refer to as kind because type is a keyword in Python, and we're going to attach a line to the token. That way we can do error handling. Every single token is going to remember its position in the line, so if there's an error with that token, or with nodes that reference that token, we know exactly where in the line we are going to have our error. We can store these two things, and eventually, we're going to give it a string. For now, I'm just going to make this empty. But soon, we're about to make another class to represent our lines, rather than just taking in a string. But let's continue. We're going to print out a list of tokens, and when we print out a list in Python, the thing that's in the print will have its __ string dunder method called, and when list has its string method called, it calls the repr method on anything that's inside the list. So since our tokens will be inside the list, we'll want to construct a repr to say how we want our tokens represented. This is going to match what we've had up until now. It's simply the first letter of the type followed by the actual string of the token in quotes. We're going to create a mark method. This will allow us to mark a token as having errors. And this is simply going to call a method that's about to exist in our line called mark, where we will take in a token and we will mark it. So this is our simple token class for now. And now we can go ahead and make that line. So I'm going to call this sourceLine.py, and we can make a sourceLine class now. This is going to feature a lot in this class because our Lexer is also going to work through this. So hopefully it won't be too confusing. We can start with a constructor. This line is a string. This is the actual line that we're taking from the user. And so we can store that. And now we need to keep track of our position in the line, but tokens may have more than one character, so we need more than one number to represent a position. So let's create something like a locale, which will be a pair of numbers. Next, we want a similar locale, but for our marks, so that we know exactly which characters in the line are marked. Rather than starting this at 0, 0, we want to start at the length of the line, which is outside the line, and -1, which is also outside the line. So what we're saying is nothing inside of the line is currently marked at the beginning. Let's create a finished method, which will determine whether we are finished reading through the line or not. And that is true when our second part of our locale, which is our endpoint, is outside of the line. And notice that this is greater than or equal to, since the last index is the length -1. Now, let's create a useful method called next, and what this will do is it will refer to the next character that we want to work on. Now, we have to be careful, because what happens if our index is outside the line? Well, how about we just return a string containing end of file if we are finished? Otherwise, we will return the character that is at this locale. Now let's implement a method for taking that, which will actually adjust our state. Sometimes it will be useful to know exactly which character has been taken, although there will be times when we won't use it, but let's store the value, and then we can increment our locale. But once again, we want to be safe, so we'll add 0 if we're finished, otherwise we'll then increment if we're not finished. Then we can return the symbol that we took. Next, we want an ignore method, which allows us to just ignore our current locale. This will be useful for spaces, for example. Let's create a taken method. The issue is our take only returns one symbol at a time, so if we want to keep track of a multi-character symbol that we have, we would need to build it ourselves using a string and using our take. So how about we just return exactly what we're already storing using our locale. Now, when we make a token, we want to give it a locale. So let's add a function here that allows us to take a copy of our locale, as well as the substring that the locale refers to. Notice here that the .copy, that is important, because in Python, lists are mutable, so if we just said self.locale, that would be a reference to this list, which in our other methods is constantly being changed. But we want just a snapshot of that locale when the token is created. We then want to essentially do what we did with the ignore method and move beyond everything we've taken, and essentially our locale will now have nothing taken, and then we can return the locale and the string. Now if we come into our token class in the constructor, we can now have a self.locale and a self.string, which we can take as the result of a new locale. There's only one thing we probably want to do. Currently, if we reach the end of our list and we have an end of file, our end of file will be represented as an empty string. So I'm just going to say our string is our string, or it is end of file, meaning if the string is a falsy value, which an empty string is, then we will get end of file. Otherwise, we'll simply get the string. We can go back into our source line now. And how about we implement that mark method, which we said takes in a token. Now what we want to do is we want to set the beginning of our marks to be the minimum between two things. One is the start of our token and what we already have marked. We can do a similar thing for the upper bound as the max between the end of our token and what we already have marked. So this way, we just grow a list of marks through the line. Lastly, we'll need one last method, which will allow us to print out those nice caret characters underneath error tokens. So let's construct this string and then return it. Now what we want to do here is, for I in range, length of self.line +1. Now the +1 is important because if there's an error with the end of file character, we want to be able to put an arrow underneath that. There's two conditions under which we want to add a mark. One is if self.marked at 0 is less than or equal to I is less than self.marked at 1. If our I is between our marks, we want to add a mark to this string. But there is one other condition, which is if self.marked at 0 is equal to I. Otherwise, we'll add a space. Now, the second part's important because if we had come in here and said that I is less than or equal to self.marked at 1, then we would always get one extra caret that we don't want. But with our current condition, if self.marked at 0 is equal to self.marked at 1, then we won't get a mark. But we do want a mark when that happens, so we have to add this second condition. So that's our source line class. Now we can actually begin to build our Lexer. But first, let's create a new module and call it util, just for our utilities and things. And add a new file to it called error.py. And in here, we'll just create a simple language error, which is in Python a runtime error. Let's give it a constructor with a message. Now, in order to utilize all of the mark system that we've created, we also need to pass it a component. So every time we raise an error, we'll have to give it a component. And what we can do is call mark on it. Now this component could be a token or it could be a node. And we also then want to reference the line as the line of the component. And we can create a string here so we can print out the language error. And we can return self.line.getMarks, which we just implemented. And then the line after, we can print out name of our error, because we're going to create subclasses off of this, followed by whatever the message is. Now, in Lexing, we can come in here and create a Lexer.py. And in here, we can now import our error that we just created from, not for, as well as our token. Now we'll create two classes. One is a simple Lexer error, which itself is a language error. And we can actually create our Lexer finally. The constructor will take no arguments, but it will keep track of the source line. Next, we need a new token method. Since every token needs a line, we don't want to have to enter this every single time. Now we can create a makeTokens method, and here we will take the line and we will store it. This way our Lexer is reusable. Every single line we just pass into this method here, and then we can return a list of tokens. Now what we want to do is we want to loop while our line is not finished, and here we will add tokens. So first, let's just create a few empty methods that we're going to need. We're going to need an ignore spaces, a make token, a make punctuator, a make operator, and a make number. So now, the first thing that we want to do is we want to ignore any spaces. We'll implement what that does in a moment. Then, in case the entire line was spaces, we want to check, well, what if after removing the spaces, the line is finished? Well, then we want to break. Otherwise, we want to add a new token to our list. Tokens. And there's one last thing here. It is useful if we append an artificial end-of-file token. Punctuator. Now, how do we want to ignore spaces? Well, how about while the next character is a space, we can take it and then we can ignore it. Now, we can begin making our tokens. Let's start with punctuators. If the next character is in this list of punctuator symbols, then we can return the token that will be constructed by makePunctuator. If the next is in this list of operator symbols, then we will return a new operator. Next, if the next character is in the list of symbols for a number, which includes all of these digits as well as the decimal point, because in our language, it's okay if a number starts with a period, then we return make number. Otherwise, there is some character that our language doesn't recognize. So what we can do is we can take that character and then we can raise a Lexer error. It needs a component, so let's construct a new token which will have the character that we just took. We'll give it just a question mark kind so that it will print that out. And then we can say unrecognized symbol. So now, before we even implement how we make all of these tokens, if we run this, well, first, in main, we have to import our Lexer. Then we can construct a Lexer object. And instead of printing the line, we can say tokens is equal to Lexer dot make tokens, and we give it our line. Now we'll want to print our tokens, but let's see what happens if we enter a symbol that isn't recognized, like this. We get an error. So there's a few things here. First, I forgot, we also need to create our source line. And instead of passing in the line, what we want to pass in is source line version of it. But that's not the only error. If that error is correctly raised, it just ends the program. So instead of that, what we should do is take all of this and put it inside a try except. Which means now we have to import our error from util error import our language error. And so we can try to loop until we get an error, in which case we can now print the error. And because we defined our dunder string method, it should print something that actually looks nice. So if I enter an unrecognized symbol, we almost got it, but what we were missing is 2 spaces of padding. So if I go into here, our marks shouldn't be an empty string, it should be 2 spaces, I believe. If we try it again, the arrow is exactly where we expect it to be. Okay. Now, we can actually implement these make functions. Our punctuators are pretty simple. They're all just one single symbol, which we can take, and then we can create the new token, and we can label it punctuator. operators are similar, except we also have a star operator in our language, which is 2 symbols. So what we need to check is if the first operator symbol we have is a star, and the next symbol is also a star, then we should take that one as well. And then we can return a new token and call it operator. Our numbers will be a little more complicated, but pretty simple overall. While the next character is in this list, which I will simply copy and paste from above, all of these possible digits or decimal places we will simply take. And then we can make a new token, and let's call it number. Now there is one thing we need to be careful of here. We need to ensure that in our taken, in all the symbols we have no more than 1 decimal point. So we need to ensure that the number of decimal points is less than 2, because it is totally possible that the user could enter something like 2.2.2.2, which is not a valid number in our language. So long as there is 1 or 0 of these decimal places, we can simply return the token. But otherwise, we need to throw an error, and our component is the token we've constructed. And then we can give a useful error, something along the lines of numbers can have, at most, 1 decimal point. So let's see where we're at. If I type 5 plus 5, we get a list of tokens. A number 5, an operator plus, a number 5, and an end of file. Let's try causing that last error that we fixed, 2.2.2. Okay, that is not working as expected. Let's see where I went wrong. Okay, I figured out the problem. The problem is, when we construct the new token, our taken is reset, so that condition's never true. So what we want to do is, instead of storing our token, which I thought was making the code simpler, we just need to call it twice. And now, if I do 2.2.2, you see, we get the exact number of carets that we expect, and we get our error. It says it's a Lexer error, and our message prints through. So now let's just try a few more different expressions. Things that may or may not make sense. Okay, so that's our Lexer working, and in the next episode, we'll start work on our parser.